We've mapped the stars. We've taken pictures of galaxies so far away, their light has traveled for 13 billion years just to reach us. We have even detected the faint, lingering echo of creation itself. We look out into the vast darkness and pat ourselves on the back for starting to understand the universe is barely a footnote in the real story of the cosmos. But what if I told you that everything we've ever seen, every star, every galaxy, every glowing nebula, this is about a deep, fundamental blind spot in how we see, well, everything. Today we're not just looking at the stars. We are taking a journey to the very edge of human understanding, into the shadows of the cosmos, to ask the biggest question of all. What are we missing? What if I told you that 95% of reality is completely missing? This isn't just about what we don't know. The invisible universe, our journey starts with something simple, something we can see. Pick any spiral galaxy. It's a majestic pinwheel of stars, gas, and dust, spinning in the void. Now, we know the laws of gravity. We can measure the mass of all the stuff we can see in that galaxy, add it all up, and figure out how fast it should be spinning. So fast that, based on the matter we can see, they should have ripped themselves apart billions of years ago, flinging all their stars into the intergalactic darkness. And yet, here they are. They're held together by an invisible glue, a phantom mass we can feel but can't see. It doesn't seem to care about most of the forces that run our world, except for one: gravity. We can't see it, but we see what it does everywhere. It's like a cosmic scaffolding, a vast, invisible web that the entire structure of the universe is built on. Galaxies and galaxy clusters form in the densest knots of this web. Without it, we wouldn't be here. Simple as that. But there's a problem, a galaxy-sized problem. They're all spinning too fast, dangerously fast. Scientists call this mystery dark matter. It's a substance that doesn't absorb, reflect, or emit any light at all, which makes it totally invisible to our instruments. It just makes sense. The gravitational pull of everything in the cosmos should be acting like a giant brake. But in the late 1990s, two separate teams of astronomers studying distant exploding stars made a discovery that completely shattered. But even after building some of the most sensitive detectors ever imagined, deep underground to shield them from cosmic rays, we've found nothing. The hunt has come up completely empty. Now imagine you throw that ball, and instead of slowing down, it rockets away from you, faster and faster into the sky. That's what our universe is doing. Something is actively pushing space itself apart, a repulsive force that overpowers gravity on the largest scales. While normal matter, the stuff we're made of, is a measly 5%, and dark matter is about 27%. Dark energy makes up a stunning 68% of the universe. 95% of the cosmos is made of dark matter, and dark energy, things we can prove exist, but whose true nature is a complete and total mystery. It's a wild feedback loop. The universe expands. Black holes get more massive, which creates more dark energy, which makes the universe expand even faster. This is still a very new and hotly debated idea, but some studies have pointed to a possible correlation. It's like mapping the entire Earth, but only being able to see while the continents themselves remain dark and unknown. One controversial new theory suggests a mind-bending link. Supermassive black holes could be the engines of dark energy. Scientists noticed that black holes in ancient galaxies seem to be getting more massive than can be explained by just eating stars and gas. This new idea suggests that as the universe expands, black holes also grow in mass by coupling with the expansion itself. In this model, the black hole isn't just a point of infinite density. It's a source of vacuum energy. But here's the really unsettling part. Dark matter outweighs all the visible matter in the universe. Planets and gas combine by about 6-1. It makes up roughly 27% of everything in the cosmos. For decades, the leading candidates for what dark matter actually is were hypothetical particles, with sci-fi names like WIMP's Weekly, interacting massive particles. Or this has forced scientists to get creative. Some newer theories propose that dark matter might not have been dark from the very beginning. In the super hot, high-energy soup of the early universe, it might have started as massless particles, zipping around like light. But as the universe expanded and cooled, these particles could have collided and condensed, like steam turning to water, suddenly gaining mass. It's an exciting idea because it might leave a unique, subtle signature in the leftover radiation from the Big Bang, meaning we might be able to test it with data we already have. So, that's 27% of the universe, an invisible, unknown substance. What about the rest? This is where it gets even weirder. For most of the 20th century, we assumed the expansion of the universe, discovered by Edwin Hubble, was slowing down. The expansion isn't slowing down at all. It's speeding up. Imagine you throw a ball into the air. You expect it to slow down, stop, and fall back. We call this force dark energy, and it is, by far, the main ingredient of our reality. Think about that. For years, the leading idea was that dark energy was just a property of empty space itself. But what if its source is something we already know? If this is true, it would mean the most destructive objects in the universe are also the source of its creative, expansive power. Echoes of creation, the mystery of dark energy decides the fate of our universe. But an even deeper secret lies at its very beginning. We can look back in time, almost to the start, by looking at the cosmic microwave background, or CMB. This is the oldest light in the universe, a faint microwave glow filling all of space. It was released when the universe was just 380,000 years old, and it's basically a baby picture of the cosmos. Back then, everything was an almost perfectly smooth, hot, dense plasma. Almost perfect. There are tiny temperature fluctuations in this afterglow. Little variations that were the seeds of all future galaxies and voids. Our best model of cosmology predicts the sizes of these spots. And for the most part, the map matches the predictions perfectly. A void like that, maybe 1 billion light-years across, could make light from the CMB lose energy as it passes through, making it look colder to us. And sure enough, surveys have confirmed there is a region with less matter there, known as the iridness. This has led some researchers to keep more exotic explanations on the table. The most tantalizing possibility of all is that the cold spot isn't caused by something in front of it, but is a genuine feature from the beginning of time. Our flagship observatory, the James Webb Space Telescope, was built to see the cosmic dawn, and it's finding things that shouldn't exist. According to our models, the first galaxies should be small and messy, but Webb is finding massive, well-structured galaxies shockingly early in cosmic history. We are seeing a surprising number of these galaxies, far more than we expected. Even stranger are the supermassive black holes at their centers. These things, millions or billions of times the mass of our sun, simply shouldn't have had enough time to get that big. It's like finding a full-grown oak tree a few days after planting the acorn. We're clearly missing a huge piece of the puzzle of how the first things in the universe formed. Some have controversially suggested it could be a bruise on our universe, left over from a collision with another bubbled universe in the distant past. Are we in an endless cycle of bangs and crunches, or did our universe pop out of something else entirely? We don't know. That is the wall at the edge of our knowledge, except for one massive anomaly. In the direction of the constellation Eridanus, there is a patch of the sky that is unnaturally large and cold. It's known as the CMB cold spot, and it's way bigger and colder than our standard model of physics says it should be. For years, this was one of the biggest puzzles in cosmology. One leading explanation was a supervoid, a colossal region of space between us and the CMB that is strangely empty. But the debate is far from settled. The supervoid, while real, doesn't seem to be empty enough on its own to explain the entire cold spot. And the mystery of our origins doesn't stop there. This forces us to ask the ultimate question. What happened before the Big Bang? Our physics just breaks at that moment. Was there a universe before ours that collapsed? These are some of the biggest questions we've ever dared to ask. The fact that we don't have answers isn't a failure, it's an invitation. It means the era of grand discovery is far from over. If you find these mysteries as captivating as I do, make sure you subscribe and ring that bell, because the secrets we're about to explore next are even stranger. The ghostly giants. What if one of the biggest secrets in the cosmos could solve two of its greatest mysteries at once? What if one hypothetical object could be the dark matter we've been hunting for, and explain how supermassive black holes got so huge, so fast? Meet the primordial black hole. When we think of black holes, we think of giant stars collapsing at the end of their lives. But there might be another kind, born not from dead stars, but from the raw, chaotic energy of the Big Bang itself. In the first few moments of the universe, it was so dense that random ripples could have been enough to crush matter directly into a black hole. No star required. One could be as light as an asteroid, but the size of an atom. Another could be thousands of times the mass of our sun. Because they have gravity but don't interact with light, they are a perfect candidate for dark matter. The long, fruitless search for new particles might have been a red herring. Researchers are proposing some brilliant, if incredibly difficult, methods. One idea is that a PBH passing through a star or even Earth would leave a microscopic tunnel or trace that we might one day identify. Maybe dark matter isn't a new particle at all. Maybe it's just a huge, unseen population of ancient black holes. While current research suggests PBHs probably can't account for all of the dark matter, they could still make up a significant chunk. The larger ones could have also acted as the seeds for the supermassive black holes we see in the early universe, giving them the head start they needed for their impossible growth. These are primordial black holes, or PBHs, and they could be anywhere and have any mass. For so long, the focus was on the incredibly small world of particle physics. Now, realizing the answer to one of science's biggest questions might be written on the largest scales, hidden in the fabric of the cosmos itself. This idea has gained a lot of ground, because it neatly solves several problems. The challenge, of course, is finding one. How do you spot an invisible, atom-sized black hole? The search for PBHS is a huge shift in thinking. The big question: what else are we missing? We've journeyed through the dark universe, the puzzles of creation, and the theory of ghostly, ancient black holes. These are the known unknowns, the mysteries we know we don't know. But the history of science teaches us that the biggest breakthroughs come from the unknown, the things we have uneven thought to ask about yet. We've got fast radio bursts, or FRBs, unbelievably powerful, millisecond-long blasts of radio energy from billions of light-years away, and we still don't know what makes them. We've found weird objects that pulse in strange patterns we've never seen before, and the universe is full of them. We find things that leave us completely baffled. These anomalies are the cracks in our current understanding of physics, and it's in those cracks that new discoveries are made. There are smoking stars that seem to be puffing out clouds of dust for no reason we can figure out. Right at the center of our own galaxy, there's a chemical reaction happening that shouldn't be, leading some to speculate it could be caused by a new type of dark matter particle destroying itself. New particles that live in a sort of parallel world, barely interacting with our own. Extra dimensions of space, curled up too small for us to see. These might sound like science fiction, but they are serious ideas that physicists are looking into to explain the huge gaps in our knowledge. Astronomers are constantly picking up signals they can't explain. Even in our own galactic backyard, we find oddities. Every time we build a new telescope, we don't just get better pictures of the things we already know about. What could these discoveries be? Are there fundamental forces we haven't found yet? We started this journey by facing the fact that 95% of our universe is missing from our view. But what we've discovered is that this isn't an emptiness. It's a space filled with questions, with potential, and with the promise of discovery. The dark matter holding our galaxy together is a mystery. The dark energy pushing our universe apart is a mystery. The moment before the Big Bang is a mystery. These aren't just little details to fill in. They're giant signs that our map of reality is, at best, a rough first draft. The greatest secrets of space aren't just waiting in distant galaxies. They're in the very fabric of space-time, in forces and substances that are all around us, yet still beyond our grasp. And if you want to be part of this exploration of the universe's biggest secrets, don't forget to like and subscribe. Thanks for watching. Our journey has shown us one thing for sure. We are not at the end of discovery. We are at the very, very beginning. Keep looking up, and never lose your sense of wonder. The cosmos is not a book we've almost finished reading. It's an entire library, and we've only just opened the first page. So, stay curious. What cosmic mystery fascinates you the most? Let me know in the comments below.